Hello, my name is Eduardo Deresa, Applications Engineer working in the Timing Products Business Unit at ON Semiconductor. Today I'll be discussing USB 3.1 redrivers for tablet and active cable applications. USB comes with a very long history, dating back to 1996 where they introduced USB 1.0 at 1.5 megabit per second. Later in 2000 they introduced USB 2.0 at 480 megabit per second, and the last couple years they've introduced USB 3.1. Gen 1 operating at 5 gigabit per second, known as Super Speed, and Gen 2, which is 10 gigabit per second, known as Super Speed Plus. In addition to these new data rates, they've also introduced a new connector, the USB Type-C connector. This USB Type-C connector is reversible and offers connectivity to multiple end devices such as laptops, tablets, PCs, and monitors and smartphones. This one cable has the ability to interface to all these end devices with one single cable and eliminates the need of having individual cables for each end device. But with higher frequency means more insertion loss over the transmission line. Over the transmission line means cables, PCB, and the connectors being used to transmit between a host and a sync device. The best way to overcome these insertion losses is to use a signal conditioning device such as a redriver. But not all cables in FR4 trace lengths are created equal. Cable insertion losses may vary from vendor to vendor. Cable gauge, type, and connectors are huge contributors to the loss performance of the cable. FR4 insertion loss vary due to the trace length, the dielectrics being used, and the routing. But both cables in FR4 losses are dependent on the data rate being used. For an example, 9 inches of FR4 has roughly 3.9 dB worth of loss at 5 gigabit per second, but has 6.9 dB worth of loss at 10 gigabit per second. Now, if you go to 24 inches of FR4, now your loss at 5 gigabit per second goes from 3.9 to 9.6 and goes from 6.9 dB to 16.8 operating at 10 gigabit per second. So with this increased insertion losses, there is a need for a signal conditioning device such as a redriver. I would like to demonstrate the connectivity between a tablet and a solid-state drive and demonstrate how it is highly dependent on the cable that's being used, which is kin as the transmission medium for the connectivity between the two devices. I will be using a Google Pixel tablet. I'll be using roughly 4 meters of cabling, a Samsung solid-state drive, and lastly, I'll be using the NB7V PQ702M demo board. I'm going to go ahead and demonstrate that the tablet connectivity between the tablet and the solid-state drive is highly dependent on the transmission medium of which the data is being transferred over, which will be this cable. I want to show that with a short cable, the tablet should recognize the device. Now when we add more cabling, more insertion losses being added to the system, which the tablet may or may not recognize it. And if it does not, we will use a redriver to reestablish the link. So first I'm going to start off with a short cable. I believe that the losses of the short cable should be low enough for the tablet to recognize. And there we go. We made a USB connection, USB 3.1 at a 5 gigabit per second data rate. Now I'm going to go ahead and add 3 meters of cable to the system. By doing this, I'm increasing, if not tripling, the amount of losses going through the system. So let's see if the tablet can recognize the solid-state drive after this 4 meters of cable. Once I plug it in, you can see that the USB connection was immediately dropped due to the fact that 4 meters of cable has tremendous losses. The tablet was not able to recognize it. Now let's go ahead and plug in our NB7V PQ702M demo board, which is our dual channel redriver, and see if we can establish a connection. Plug in our demo board, refresh, and immediately you see a USB connection pop up. USB 3.1, 5 gigabit per second connection between the tablet and the solid-state drive was made with our redriver and 4 meters of cable into the system. Now let's go ahead and remove the redriver to see if there's still a connection between the tablet and the solid-state drive. So redriver was removed, plug that back in, and immediately you see that the USB connection was dropped. So this 4 meters of cable, no established link between solid-state and tablet. But let's reduce the losses once more to 1 meter to see if the tablet can still recognize it without a redriver. Okay, shorten the amount of losses to just 1 meter, and there you go, a USB established connection was made. For more information about our USB redrivers, visit us at www.onsemi.com. Thank you very much.